Welcome to question 8 of the 2015 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. For question 8 we have events A and B from a sample space such that the probability of A given B has occurred is equal to 3/4 and the probability of B occurring is 1/3. And we are asked to calculate the probability of A intersecting B. So because we have a conditional probability, we could use this formula from the formula sheet that says that the probability of A occurring given B has occurred is equal to their intersection, the probability of A intersecting B, divided by the condition, which is the probability of B. Therefore, if we want the probability of A intersecting B, which is what the question asks for, we can multiply by the denominator, which would give the probability of A given B times by the probability of B. So therefore, the probability of A intersecting B is going to equal the conditional probability of A given B, which from the question we know is 3 divided by 4, multiplied by the probability of B, which is 1 divided by 3, which is just equal to 1/4. So that is the answer to this question. From the examiner's report, we can see that this question was well answered, with 87% of students getting this question correct. For part B, we're asked to calculate A' intersecting B, where A' represents the complement of A. So for questions where you're given two events A and B and you're asked to find the intersections, a Carnot map or probability table can be a really useful way of storing our information. So I'm going to set this up as A and A complement, B and B complement, and we know the probabilities always add up to 1, so there's a 1 in that cell. And now we're told the probability of B up here is equal to 1/3, which is the same as 4 on 12, just so we have a common denominator with the rest of the entries in the table. So that information goes here, so that's 4 divided by 12. And for part A of this question, we found that A intersecting B had a probability of 1/4, which can be written as 3/12. And now the probability of A complement intersecting B is this cell here, which we know we have 3 on 12 plus 1 on 12 will give 4 on 12. So therefore, the probability of A complement intersecting B is going to equal 1 divided by 12. So that is the answer to part B of this question. From the examiner's report, we can see that almost 60% of students got this question correct, and that a Carnot map was the most useful way of formulating a solution to this problem. Some poor manipulation of fractions was evidence in the response, and in getting a common denominator of 12 may have helped to avoid that. For part C, it says if events A and B are independent, calculate the probability of A union B. So if events A and B are independent, then we know a few things about them. The first thing that we know is that the probability of A given B has occurred is simply equal to the probability of A occurring, because if A and B are independent, the probability of A given B, knowledge that B has occurred, has no effect on the probability of A. So A given B was 3/4, so that's now the probability of just A, and with a common denominator of 12 we can write that as 9/12. The other thing that we know if A and B are independent is that the probability of A intersecting B is equal to the probability of A times the probability of B. And that's going to equal the probability of A is simply 9 on 12, or 3 on 4 I'll use at this stage, times the probability of B of 1/3, which gives 1/4, or that can be written as 3 on 12. So the reason why we've discussed those two things is that helps us to use the addition rule for probability that says the probability of A union B is going to equal the probability of A plus the probability of B minus the intersection, so the probability of A intersecting B. So therefore, the probability of A union B, which we were asked to calculate, is equal to the probability of event A, which we just discussed to be 9 on 12, plus the probability of event B, which we knew could be written as 4/12, minus the intersection, which was 3/12. And when you add those fractions together, you get 4 plus 9 is 13 minus 3 is 10/12, and that gives the answer of 5 divided by 6. And it's important when you're answering a question with fractions to simplify fractions like that. Many students made very little headway into solving this problem due to a lack of understanding of what independent events are. And to elaborate on that, we'll just write out the useful things that we know about independent events. So if A and B are independent, we know the following. We know that the probability of A given B has occurred has no effect on whether or not A occurred, so it's just the probability of A. We know that the probability of B occurring given A has occurred has no effect on whether or not B is occurring, so it's just the probability of B. And we know that the intersection, probability of A intersecting B, is equal to the probability of A multiplied by the probability of B. So the third statement there is probably the one that you know the most about or you've seen most often, but the two above it are really important understandings of what independent events are and how it relates to their probabilities. Furthermore, the examiner goes on to state that the addition rule was then applied using an incorrect value for the probability of A for many students, resulting in final answers well outside the interval 0 to 1. Students must note that probabilities must lie within that interval of 0 to 1, and they are never a negative number. So that is an understanding that students need for probability.